Hey gang, here we are with the third lesson of Unit 6. This lesson is all about powers of monomials. An example of powers to monomials is, if you look right here, we have the quantity 4x to the third quantity squared. That is an example of a power of a monomial. So we have two steps we're going to look at, and then we're going to write our power rule. So step one is that we are going to raise the coefficient to the outer exponent. And step two, we use the power rule to simplify the exponent. But what is that power rule? Well, let's look. If we have a coefficient to some power that we'll call m, that whole quantity to the nth power, what we do is that we multiply those two exponents. So this would become x to the m times the nth power, whatever that works out to be. So if we apply that to our example right up top here, we want to apply that outer 2 to the coefficient. So 4 squared would give us 16. And then for the x, we have the 3 times the 2 following the power rule, so that would give us x to the 6th power. So let's look at a few more examples down below. For number 1, we have x, the quantity of x squared to the 5th power. So we multiply those exponents, 2 times 5, that gives us x to the 10th. And number 2, this one's a little tricky because we need to remember that C has a power of 1 and D has a power of 2. So when we look at that whole quantity to the 3rd power, we need to make sure that we distribute that to both those exponents. So C to the 1st times 3 would give us C to the 3rd, because 1 times 3 is 3, and D to the 2nd to the 3rd power gives us D to the 6th power. So these can be a little tricky, so make sure that you pay close attention to those exponents and the coefficients. For number 3, that -4 is sitting outside of the parentheses. So that does not get touched by that 3rd power. That's very important to know. If it was inside the parentheses, then we would be applying that 3rd power to it. But since it's not, we're going to ignore that. So I'm just going to drop down that -4. We have m to the 1st to the 3rd power. So 1 times 3 would be 3. So that's m to the 3rd power. Then we have n to the 4th quantity to the 3rd. 4 times 3 gives us n to the 12th. So there's your answer for number 3. Let's look at number 4. Notice in this case, this 2 is inside the parentheses. So that exponent of 5 that's sitting outside the parentheses is going to be applied to that 2. So we need to think about what's 2 to the 5th power. Well, when you plug it into your calculator, if you just think 2 times 2 times 2 times 2 times 2, that's going to give us a 32. And then x squared to the 5th power gives us x to the 10th. And y to the 1st times to the 5th power gives us y to the 5th. Number 5, same thing. We're going to apply that 3 to the negative, that 3rd power to the -3. Think about this. If you're going to multiply a negative number 3 times, that's going to make it negative, because a negative times a negative would be a positive, times a 3rd number that's negative would give us negative. So -3 to the 3rd power is a -27. Then we have x squared to the 3rd power. That gives us x to the 6th. For number 6, let's think about this. Fractions are not scary. 1/2 times 1/2 times 1/2, because we're going to apply that 3rd power to the 1/2. Remember, we just multiply straight across. So 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. So Simplifying that, we start off with 1/8. Then we have a to the third, which is a to the 9th. Then we have b to the 4th to the 3rd, which would be b to the 12th. And c to the 5th to the 3rd, which would be c to the 15th. So at this point, I'm going to ask you to pause the video, and I want you to try numbers 7 through 12 on your own. Once you have completed those, unpause the video and check your answers. All right, welcome back. As you can see, here are the answers for 7 through 11. I'm going to walk you through number 12, as that one's a little more challenging. But when we look at these, specifically look at number 9, 10, and 11, since we're multiplying, what we want to do is simplify our monomials with exponents. So as you can see, here's the simplification of them. And since these quantities are being multiplied, we need to apply what we learned in the last lesson when we multiply monomials. When we multiply them, we just add the exponents. So we have x to the 9th times x to the 1st, that gives us x to the 10th. Y to the 9th times y to the 2nd, that gives us y to the 11th. Same thing here when we're applying these. A to the 3rd times a to the 2nd. Well, first thing we got to do is we got to distribute this 4th power across these and then combine the terms. So that's x to the 6th, and then b is to the 4th power. Well, sorry about that. I realized I just wrote the wrong answer here. Let me fix that real quick. For number 10. Number 10 should be a to the 3rd gets dropped down times a to the 8th power, b to the 4th power, and that would equal a to the 11th, b to the 4th. All right. So let's look at number 12. Number 12 is a little more challenging. First thing we're going to do is simplify. So we're going to distribute this 3rd power to everything. So 6 to the 3rd is going to give us 216. A to the 6th, b to the 3rd. That's being multiplied by 1/3 squared becomes 1/9. A squared, b squared, c squared. And when we combine those together, 216 times 1/9, we multiply straight across, so 216 times 1 would be 216 over 9. When you divide that, that gives us 24. And then we add the exponents, so a to the 6th and a to the 2nd is a to the 6th power, the 8th power. And then we have b to the 5th and c squared, because that remains by itself. For the last two, 13 and 14, we're going to distribute, so we're going to simplify this. We get 8a to the 6th plus 3a to the 6th. Since these have the same coefficient and exponent, we can add them, so that gives us 11a to the 6th. So this is just a reminder of going back to our first lesson when we were adding monomials, adding and subtracting monomials. For 14, same thing, we want to simplify. So 3 to the 4th power is 81, x to the 12th, y to the 4th, minus, distribute this 2 across that, that will give us 7 squared is 49, x to the 10th y squared and that's being multiplied by x squared y squared. So I'm going to drop this down, 81x to the 12th y to the 4th. And we have these being multiplied together. So we multiply them together, we add the exponents, so that's minus 49 x to the 10th times x to the 2nd gives us x to the 12th. Y squared times y squared would be y to the 4th. And then we simplify that because they have the same coefficients and exponents. We can do that. So 81 minus a 49 is 32. So 32 x to the 12th y to the 4th is our final answer for that problem. So those are a little more challenging, but hopefully you're getting the sense of how to work these. And that will complete this lesson. And on to the next.